Good morning to one and all. I hope I am audible. Okay, so I welcome all of you. Yes, sir. Thank you, sir. Thank you, sir. Thank you. I welcome all of you for this webinar on advanced materials in aerospace. So I request Dr. P.R. Nadarajan, sir, Chairman, IEI Coimbatore Local Chapter, to give away the welcome address.
Thank you. Good morning to everybody. On behalf of the Institution of Engineers India, Coimbatore Local Center, and the Department of Aeronautical Engineering, Hindustan College of Engineering and Technology, Coimbatore, I extend a hearty welcome to everyone. I extend a special welcome to Dr. Jitendra Kumar Katiyar, Assistant Professor, Department of Mechanical Engineering, SRM Institute of Science and Technology, Chennai, who has been kind enough to talk on the topic Advanced Materials in Aerospace. I extend a hearty welcome to all the committee members and members of the Institution of Engineers India. I also extend a wholehearted welcome to all the students who are connected. Thank you.
Thank you, sir. I request Dr. Ganeshan, sir, Assistant Professor, Department of Aeronautical Engineering, to give away the presidential award.
So I'm audible.
Yes, sir. Yes, sir.
A very good morning to all. On behalf of Head of the Department of Aeronautical Engineering, so for this special occasion, we have a very special guest. On behalf of management, higher official, and students and staff members of Aeronautical Engineering Department, I would like to give my hearty welcome to Dr. Jitendra Kumar Katiyar, Assistant Professor, Department of Mechanical Engineering, SRM Institute of Science and Technology, Chennai. Welcome you, sir. And also I thank the Institution of Engineers India, IEI, Coimbatore Local Chapter, for sponsoring this webinar. So 40 years ago, aluminum dominated the aerospace industry. As the new kid on the block, it was considered to be a lightweight, inexpensive, and the state of the art. In fact, as much as 70% of an aircraft was once made up of aluminum. Other new materials such as composites and alloys were also used, including titanium, graphite, and fiberglass, but only in very small quantities. Readily available aluminum was used everywhere, from the fuselage to main engine components. So times have changed. A typical jet built today is as little as 20% of pure aluminum, and remaining are advanced materials like composites, carbon fiber reinforced polymers, honeycomb materials, etc. In this regard, I request the students to utilize this section and understood about advanced materials used in aerospace. I would like to extend my warm welcome to all teaching and non-teaching faculty, members of Aeronautical Engineering Department. Last but not least, my special welcome to all my dear students to this great occasion. I welcome you all once again. Thank you. Thank you, sir.
Thank you, sir. Indeed, I am honored and feel privileged to introduce our guest for today. He is Dr. Jitendra Kumar Katiyar, Assistant Professor, Department of Mechanical Engineering, SRM Institute of Science and Technology, Chennai. He obtained his bachelor degree from Uttar Pradesh Technical University, Lucknow, with honors in 2007. He obtained his master's from Indian Institute of Technology, Kanpur, in 2010. He also completed his PhD from the same Indian Institute of Technology, Kanpur, in 2017. He is a life member of Tribology Society of India, Malaysian Society of Tribology, Institute of Engineers India, and Indian Society for Technical Education, etc. He has authored, co-authored, published more than 20 plus articles in reputed journals, 30 plus articles in international national conferences. He has also published 12 book chapters and 2 books, notably Automotive Tribology and Tribology in Materials and Application in Spiegel. He is also an active reviewer in various reputed journals such as Tribology, International, Defense Technology, Journal of Materials Research and Technology Materials, Research Express, International Journal of Surface Science and Engineering, and many more. He has also delivered more than 30 plus invited talks on various research fields related to tribology, composite materials, surface engineering, and machining. He has received research grants from various government organizations such as MHRD, SCRB, and so on. He has also organized 5 plus faculty development programs, short-term courses in tribology, international tribology research symposium. With this brief introduction, I request our guest, Dr. Jitendra Kumar Katiyar, sir, to deliver the lecture. Sir, I welcome you, sir.
Yeah, thank you.
Thank you, sir.
Thank you very much for your kind introduction, and thank you, Ganesh sir, for introducing me and other staff of CET Institute. So I hope you will like this lecture. Previously, in month of Feb, also I have given a lecture of basic introduction of the composite material, and I also showed you the research part in that particular composite material after mixing of MWCENT or graphene, because that is also one kind of the composite or material which is in a current trend going on recently. So today's topic is also a very generic topic there, where we will see the different kinds of the material which is used nowadays in that particular aerospace application. So how this material is developed from one stage to another stage, slowly we will see what, each slide we will see, and we can understand the things nowadays where we are standing and previously where we was. So that I have arranged the slides in such a way that you can, even though a student can also very easily understood where we was earlier and that those days, and where current status, what is the current status, and what will be the future of these materials and these aerospace material, and what is the research trend in this type of the aerospace structure material. If further any student wants to do go for the higher study, then that is also very useful. So just I'm presenting my slide. I hope my slides are visible to all.
Yes, sir. It is visible, sir.
Okay.
You need to maximize. Yes, sir. Now,
Yeah.
fine.
Now, sir, okay, sir?
Fine, sir.
Okay, so as I told you, this is a very interesting things material. So material, either you are working in aerospace or mechanical engineering, the material is most important part. How you can select the material according to the application, that is our experience. So as soon as you will grow, and your experience will also grow, and then you can suggest someone to a particular exact material which is suitable for that particular application. Like some cases we need the materials and also the environment is extreme condition, means higher temperature, so we can suggest the refractory material or refractory material alloys for like very high temperature furnaces and other things. So this material is plays a very important role in each application. Either you are you are aerospace engineer, or we are mechanical engineer or civil engineer, the material plays a very important role in making the structure, component, and equipment, whatever we want to fabricate. So this advancement of the material is also slowly going on in this era also, and next 2050 also we are targeting some advanced material in our aerospace application, or even though in civil structure also we will go for some advanced material. Those are called a smart material. So that the smart material is also various kinds of the smart material, and every smart material is used for different application, either semiconductor or your hard disk, your mobile phones, or in bridges also, so that those magnetic type of the alloy and some radioactive smart material and self-healing material, self-healing also widely used nowadays. So we will look one by one in each aspects of the material and how we can start from which material in aerospace, and now in which material we are standing, and in future which material we will use in air fabrication of the aircraft. So first we'll go for the particular, these are the topic of today's webinar. So we will look into where we stand and where to go, and how the material is evaluated or evaluation happened in the aeronautical material, and what is the current material, what are the current materials in aircraft structure, and different fabrication technique. I will not go in much detail in that particular fabrication technique of those material, like several methods. I hope you have studied in composite subject, RTM method and fused deposition method and several other method. Ester casting method also we are using to make the metal matrix composite and other things. And then we just introduce you the basic things of that particular composite classification and their applications in that particular current scenario. So our goal, whatever the aerospace industries, their goal and vision in 2020 is nothing but to reduce the this carbon dioxide emission, whatever when we fly in the air, then how you can reduce the emission, which is comes out in CO2 gas or NOx gas. So our goal and vision of all aerospace industry to make environment greener. So environment goal compared to 2000, that is now we are in 2020. So compared to 2000, we are just talking about one decade, that is 20 years before. So we are comparing from the 2000, and now we are in 2020 and 2021 we started. So reduction of the fuel consumption and CO2 emission by 50%, that is our target in this era, present time. And also we can reduce the NOx emission by 80%. And noise level also we want to reduce by the 50%, because noise pollution is also creating the heavier cargo and other things. So very high noise. So how you can reduce the noise pollution at the time of operating of jet engines. So these are our goals and visions in current scenario as comparison to 2000. And also we can reduce the environmental impact of the manufacture, maintenance and disposal of the aircraft. So we also want to do some less maintenance, because maintenance cost is also added up in that particular cost of that aircraft. So how you can develop such kind of the aircraft where less maintenance is required. Like you have, I hope you have listened, heard that the word of self-cleaning solar panel or self-cleaning glasses. So in real estate, in industry, you have seen that the multi-story building, all the glass is only used up till 11th floor. So how you can clean those particular glass? So we just use the surface of hydrophobic, so that whatever the dust particle or water particle in rainy season, it come over the glass, then immediately it can roll out and it will not dirt the glass. So that type of the glass, it is hydrophobic glass or coating over the glass. It is known as a self-cleaning of the glass. So that these type of the advances is reducing the maintenance cost. Because if you hire some person to clean every day, that at least you just give the some salary. So similar case here in also the same thing, we want to reduce the maintenance. That is our goal and vision. And also as per the safety norms, as comparison to 2000, we wants to reduce the accident by 80% and drastic reduction in human error and its consequence on the flight safety. So we just introduce the artificial intelligence or this automation in aircraft industry so that you can reduce the human error. And if you can reduce the human error in fabrication or development of aircraft, then surely we can achieve the target of reduction in accident by 80%. So these are the goals and visions in 2020 of all aircraft industries as comparison to 2000. So emission reduction or increased safety or reduced cost, these are the basic three fundamentals over which we are working nowadays. So we want to reduce the emission of CO2 and NOx. We want to increase the safety of persons who fly in the aircraft. And also we need to reduce the cost of the particular aircraft. So how you can reduce the emission and other things by reduction of the overall fuel consumption. So if you can reduce the fuel consumption, then you can reduce the emission. These are the simple dependent terms. So how you can reduce the fuel consumption? You can reduce in the parasitic drags, whatever drag it is applied over the aircraft when it runs. At least you can reduce that particular drag. And also you can reduce the weight of the aircraft. So that is weight reduction. So these things you can reduce by reducing the drag and reducing the weight. You can reduce the overall fuel consumption. How you can reduce the weight? That is optimization. We will follow it by the synergistic synchronization between the design and development of the lighter and stronger material. Because how you can reduce? We can use the aluminum or magnesium. These are the most lightest material nowadays. So mostly people are working, previously we are working on the aluminum, but it is having some disadvantages also. But magnesium is more, less weight as comparison to aluminum. So magnesium is also needs how you can improve the mechanical and other properties of the magnesium so that we can improve the design and development. So this is the synchronization between design and development. How you can make the
now it is clear. Yes, sir. Yes.
So these optimization we can perform by selecting the proper manufacturing technique. So this proper manufacturing technique is like Katiyar method, or this is not taking the too much money in manufacturing. So that also added in your overall cost of that particular aircraft. So manufacturing technique, we can reduce the process in such a way that we can reduce the cost of the final product. So we can select the proper manufacturing technique, and also we can design the concept by allowing the full advantage of the properties of advanced material. So we just design the structure in such a way that it can improve the property, not reduce the property, like fatigue property, creep property. This fatigue is very, very important in aircraft. So, and creep is also. So these are the properties, at least you can improve it by designing of a proper material. So, and by developing by proper selection of the manufacturing. So in these are all these, if we can consider early stage, then we can reduce the overall fuel consumption. That is our goal nowadays. So environmental trend in aviation from 2005 to 2050, that is analysis here, and we can international aviation fuel burn. So that is a prediction, whatever we are taking, that is nowadays we are only here. We are up to here in this stage, but we are predicting that already international aviation fuel burn, that society can predict up till 2050 how you can reduce it. So what that society is suggesting, that this baseline, this blue line, whatever you solid line, it is called a baseline, including the fleet renewal. And this sky blue color, it is contribution of the technologies improvement, how you can, if you can improve the technologies in such a way that improve the material and other things, then you can further reduce the fuel burn. So that much reduction you can do it if you can select the proper technologies and improve the structure. And this further you can add the contribution improved ATM and infrastructure uses, and further you can improve 1.39% per year fuel efficiency improved. And whatever we are targeting that this dash line, so 2% per year fuel efficiency improvement, that is our target up till 2050. So that is the basic things, and we are always a good motivator, and we just select the goal and wants to achieve that particular goal, because 2% efficiency per year fuel efficiency improved, then you can reduce lot of the money, and also you can make the environment greener. So by result of the global full light fuel burn of the international aviation, the explorated this 2050, that whatever this ATM, what is the meaning of ATM? That is called the air traffic management. So how you can air traffic management, how you can improve it, means properly you can control the traffic over in air, and you can use the proper infrastructure, that is operational improvement, because sometimes in runway, from the station to runway of one aircraft, at least it will go 20 liter or 30 liter in that runway itself. So if you can improve the operational one by controlling the air traffic management, proper management of the air traffic control, we can reduce the fuel consumption, and this is called something. So if you can proper control the air traffic maintenance or management, then 1.39% per year fuel efficiency you can improve it. That these are the few figures which is predicted by the International Aviation Fuel Burn. So further, international aviation CO2 emission also from 2005 to 250. So if you can proper control of all these three things, then we can reduce that particular CO2 emissions. So these are the minimum cap we want to achieve. So we want to close to this dash line, so that it is our means nowadays this range is like this dash line. So 2020 CO2 emission is like this, and we want to reduce this particular gap and minimize this gap, so that you can reduce the CO2 emissions from the fuel consumption. So what is nowadays, it is assuming that 1 kg of the jet fuel burn generate the 3.16 kg of the CO2 in terms of the weight. So that's why it is written here CO2 emission is equal to 3.16 times of the fuel. So if 1 liter fuel, 1 kg or 1 liter fuel is burned, then you will get 3.16 kg of the CO2 in environment. So that is very, very important to control the CO2 emission in the environment, and we make the environment safely. So we just design the material, or we can reduce the weight of the aircraft. These are the methods which I already showed you, through which you can reduce the CO2 emissions and NOx emissions. Further, total aircraft emissions, whatever it is there, it can slowly can increase it. So that that is the nowadays trend in the aviation. So this is million of the metric ton from 2005 to 2050 around. So it is NOx emission is slowly it is increasing. So flight path for 2050 objectives, whatever it is our environmental goal compared to 2000, we want to reduce the 75 to 80% reduction of the CO2 emission per passenger kilometer, and a 90% reduction in NOx emission. and whatever we can reduce the noise level up to 60 to 70% in between that range, and also aircraft movement from emission free when taxiing. So nowadays what we are doing that for taxiing the aircraft up to runway, we just use the car and we just taxi it, and taxiing is done. Otherwise what happens, if you can run the aircraft from the station to the runway, it can take approximately 20 to 30 liter fuel is burned in that particular short span of time. So we need the emission free when taxing. So that is we can reduce the fuel consumption. So air vehicles are designed and manufactured to be recyclable. It will not affect the environment. And Europe is established as a center of excellence on sustainable alternative fuel. And we also developed some sustainable biocompatible fuel like jethropal and other things, so that our fuel consumption, whatever we are using nowadays, ethane and other things, it can reduce the emissions. And safety goal like this particular, less than one accident per 10 million commercial aircraft. These are our goals.
It's 11 o'clock.
2050. And whether other hazards is the environment precisely evaluated, the risks are properly mitigated, and also air vehicles are resilient by design to current and predicted on board and on the ground security evaluation, and internally and externally of the car. And also we are targeting to means less fire proof. In month of Feb, I showed you the how we can select the composite material, so that if fire can catch, then also it cannot burn completely, and we can evacuate the passenger very slowly. So that type of the composite is safe. The safety goals aspects we required in that particular. This is the our means international aviation industry, the goal of and vision in that particular safety terms, or as well as the environmental terms. So how we can achieve it, we can develop the aero structures relies on the development of new material. So we can develop the new material. You can see this is the leaf, and this leaf you can see this water droplet, and it can roll over the surface. So we can make the more hydrophobic in nature. The structure should be more hydrophobic in nature. So self-cleaning is already done it, and we will not require hire any persons to clean that aircraft at some time. So self-cleaning is the one aspect. So by this can be achieved by the development of the hydrophobic or super hydrophobic surface. So improve specific property, also we can improve the manufacturing techniques. So we can achieve the higher strength to weight ratio, due to which you can reduce the cost. And after this consequence, if you can do it, we can also meet the environmental friendliness, so that it will not hazard the environment. So these are the few goals up to 2050. Like we will show one by one when this Wright brothers develops in 1904. The first aircraft developed by the Wright brother, everybody knows that. So they just use the 100% wood and covering the fabric only. So we just they use the wood material to fabricate this aircraft, and that aircraft for good looking, we just they use the fabric one. So this is the first material which was used in aeronautical material, and it is used by the Wright brothers, that is 100% wood and which is covered by the fabric. After this Junkers J1, that in first near to the First World War, after this wood fabrication, so this Junkers type of the aircraft, this is the Germany aircraft, and they use the 100% steel. They replace the wood, and they now 100% is steel used in the aircraft. So weight of the such type of the aircraft is very heavy, and these type of the aircraft, it is used in First World War also. Then Junkers J7, after this steel, because of the weight, they just use the 100% duralium. Duralium is nothing but it is a non-ferrous alloy, and this is widely used that time in the Junkers aircraft in the reduction of the weight. So this in this Junkers J7 we just use the 100% duralium. After this D Havilland Comet, here what we'll do, this duralium is made up by the that is a titanium alloy, and this also having the some weight. So what we'll do after this in Second World War, this mostly we can target it through the duralium. We can change the structure by 100% aluminum. So these are the evolution of the aeronautical material from the board: 100% wood, 100% steel, 100% duralium, and 100% aluminum alloy. Now it is used. And then further, what we'll do in Asian in 1953, after Second World War, this 3 March 1953, Canadian Pacific Airline Comet crash and take off at the Karachi and Pakistan. So this why this crash has happened, and after that we can design for further modify the design, and we can further improve the material after this accident in that particular aircraft, and all the passengers died because of the use of aluminum, complete 100% aluminum. So we just use the material that is a composite material. So we just use 96% metal and 4% composite. That is after 1953 accident happened. So 100% aluminum changed into the, now we just introduce slowly some part of the composite. So this A300 Airbus, this is a first twin engine wide body aircraft in the world after this 1953 or 1954. So in this we are using the 4% composite material of any European passenger large aircraft. This is 160-seater aircraft. We just little bit introduce the composite material in metals after that accident. Then further Airbus 320, we also found that the 4% composite is not sufficient to improve the property. So what we'll do, we just mix the several elements. So we mix the aluminum more in percentage because we need the lighter weight. And in this, we improve the strength of this aluminum. We just add the 6% titanium, 9% steel, 15% composite. We just increase 4 to 15%. That other alloy element like chromium and other things to corrosion and rust, prevent the corrosion and rust. So these are the few material which further added in Airbus 320. So these are the development of the material according to our requirement. And nowadays, this after Airbus 320, Airbus 380-800 material overview, we are further increase the composite material percentage from 15. So initially we are using composite only 4%, 4 to 15, and now 15 to 22%, and reduce the titanium and steel and other element also we just improve it, increase it. And aluminum also we can reduce it. So mostly panel like this is the aircraft of we use glass fiber reinforced polymer. So this color you have seen in this tail, we just use the glass fiber, and quartz fiber reinforced composite. These are the green we just use in tail. Carbon fiber reinforcement composite mostly used in that particular one. Maybe 30 to 40% use the carbon fiber reinforcement composite. Then metal is reduced in some body, like wings are made by the aluminum metal and other things, and glare is also used in that particular decoration type purpose. So these are the new material which is introduced recently. So this aeronautical material, it is several parts is there. So like nose and main landing gear, pylon and nacelle coin, and wing surface, skin fuselage, door, horizontal stabilizer, vertical stabilizer, and steering wheel, aileron, spoilers, flaps, and leading edge in that particular, or it is called a J noise. So these are the material you can see here. The mostly aluminum alloy initially was used, and these materials are made up by the composite. So either carbon fiber reinforced, glass fiber reinforced, aluminum fiber reinforced, and then also we can reinforce the titanium and steel to improve the toughness and strength of these jet engines. Or sometimes this landing gear, we need the more strength over the landing gear because whole weight just comes over the landing gear. So not movable part, we just go for the metallic one. Movable parts, we just go for the composite one. Engine and pylons, we go for the steel and titanium. Landing gears, we go for, we just choose steel because of the high strength in that particular one, and it can also absorb the shock. So these are the material it is used in aeronautical industries. So Airbus 350 composite locations like 350, these are the 50% nowadays we are using the composites in Airbus. So like you have seen in the composite evaluation, in Airbus evaluation from Airbus 300 to Airbus 350 or something, we started by adding 4%, and nowadays we just more than 50% we are using the composite material in Airbus. So 50 and you can see here the metal concentration or metal percentage we are slowly reducing, but titanium we can improve it in every aspects. You can see here we are using 5%, but now we are using the 14% titanium in the whole, because titanium provides the better strength in that particular one, and also it can sustain at the extreme environment also. So that's why this titanium, and titanium is also biodegradable in nature, bio material. That's why you have seen that the titanium alloys is used in orthopedic department. So if you want to operate your knee or hip joint, then we just go for the titanium material for knee and knee implant. So orthopedic implant is made up by the titanium, and also nowadays what we'll do in orthopedic, we just use the polymer coating, that also biocompatible polymer coating. So slowly we are moving to environment friendly material, biodecomposable material, and you can easily recycle those material. So 52% composite material, and this is the Airbus, the first Airbus aircraft with both fuselage and wing structure made primarily by the carbon fiber reinforced polymer. These are the present development in the aeronautical material. So in that particular further we just use in this Airbus 787 body the fiberglass. These are the joints made by the fiberglass. Nose is also aluminum. You can see the very less aluminum we are using. We are just using in the flap, so that we are reducing the aluminum mostly in Airbus 787. These are the recent Airbus. So this we are mostly reducing the aluminum, and all the part of this Airbus is made up by the carbon laminate composite or carbon sandwich composite, and a very less amount of the aluminum, steel, and titanium material where we need the high strength, because these jet engine we can at least hold by this wing and flap. So this for holding purpose it needs a strength. So that's why we just use the metal, aluminum, steel, and titanium, which provides the more strength, and it can hold properly to these jet engines. So Boeing 787, you can see here in very sectional view of this aircraft, and how this can we done it by this floor of that particular one. Yellow is fiberglass, and blue is nothing but toughened carbon fiber glass and hybrid things also we are using. So this also we are using here nowadays. Boeing 777 aircraft, we use the fiberglass, mostly toughened glass, and hybrid one also we just mix with the composite and metals. So that is hybrid one. We just additives to improve the strength of each and every material of the aircraft. So this Airbus 380, you can see the different cross section, and in this particular Airbus, we can use the composite material 60% by weight and 80% by volume. So mostly we are moving into the lighter weight. So when you reduce the weight of the Airbus, then you can improve the fuel consumption, and it will not consume more fuel because of the light in weight. So that's why if you want to the higher average through your bike also or automobile four-wheeler, then you can reduce the weight. Then you will get the higher efficiency of your engine. Like Splendor or Bajaj Platina, why those bikes gave you the more mileage? Because the lighter in weight. But Bullet is not giving that particular mileage. It is giving only 20 or 30 or 25 because of the more weight. So if you can reduce the weight, then you can increase the efficiency of the engine. So that is our aim also. Nowadays in automobile also we are using the composite material to improve the strength as well as to reduce the weight of the vehicle, so that you will get the more mileage from that particular vehicle. So these are the various evolution of the aeronautical material in starting 1904 to till now, and now we'll move to the future. So so in this particular weight reduction, what we have seen that Airbus 380, which is 60%, has the lowest percentage of the aluminum by weight of all flying Airbus model, and 20 different alloy and tempers compared to 6 utilized in Airbus 320 or 330 aircraft. So it is a very advanced aircraft, Airbus 380. So it is features all application of new material, glare and fuselage skins, so improved fatigue and impact property at the lower density than exists the material. So that is why in Airbus we are using mostly composite material, hybrid composite material, to improve the fatigue and impact property. These are the few mechanical property which is very, very important for your aircraft. So carbon fiber reinforced and glare in Airbus lets the weight reduction of the 15 ton compared to what would be if metallic material was used. So in this aircraft we are reduce the weight 15 ton as comparison to the metallic material if we are using in that other Airbuses. So composite uses over the years in aircraft industry, here you can see, as I told you, only 4% it is used, 4 to 5%, 1960 to 1970. After this 10 years, another decade, it can improve up to 8%. After this next decade, we just improve the 12%. And nowadays, we are using to 50 to 70% composite material in this Airbus, and our target is to improve this composite material percentage in the Airbus. It is 70 to 80%. So if we are targeting 80% composite material, only 20% metal, and so if we are using the composite, then in composite, how you can improve the fatigue life, impact strength, fatigue strength, and temperature, because the composite is having lower temperature than the metal, and how you can improve the temperature so that it can also sustain, it can be sustained in fire also. So many tests we will perform, this flammability test and other tests in composite to improve this, because we are moving in this era where 80% aircraft is made up by the composite, only 20% we will use the metal. So those metal we will use in that particular landing gears and few flaps. That's it. Because landing gears we can't made up by the composite, because composite cannot absorb the shocks and other things. So that's metal can be good for that particular application. So that's why 20% is very less material we will use, and we can try to reduce the weight of the aircraft by 20 to 25 ton as comparison to the previous one. So these are the current situation according to the specific strength. So we need the good strength to weight ratio, or we need the good stiffness to weight ratio. These are our aim in that particular material, because we are targeting to use the 80% composite in aircraft application. So we are here nothing but we just add the polymer, and in this we just add some fillers. So we just make the reinforcement and matrix, we make the composite. So this composite, glass fiber composite, also we need to make the biodegradable biocomposite. So in that particular biocomposite we can add the Kevlar, hemp fiber and aramide fiber. These are all called biocomposite fillers, and carbon fibers, polyester, these are ceramic one. But mostly we are using the this flax, hemp fiber, flax or Kevlar. These are the biocomposites. So we are also targeting the biodegradable composites in use of this aircraft to reduction of the weight, so that we can improve the efficiency of the fuel consumption. So biodegradable composite can be degraded easily in environment and also not hamper the environment. So because of that reason, and also if we can make the biodegradable composite, in those composite we need the good strength to weight ratio and good stiffness to weight ratio. If we can achieve these things, then that material will be a successful material for aircraft applications. So we are working nowadays in this zone. In this zone we are working it, and we are targeting to improve more strength to weight ratio and more stiffness to weight ratio, so that slowly we can up till 2050 we can target 100% composite material in the aircraft. So what is the composite material? Because that is very important in fabrication. So composite is nothing but it is a mixture of the two or more distinct material to improve the property. So each material having its own property. So if you can add single, then that will not serve the purpose. So what you will do, you can just add 2 or 3 elements, and because of each element having its own property, we can improve the complete property of the composite. So like in a project group, in a final year project, or you will do it. So why we will select the group? Because each student have its own capability. Some student is good in entertainment, some student is good in software, some student good in English writing, some student good in the thinking, some student good in that particular experiment. So we just select the group, and one leader is required who can handle the group. So that who can club that particular group. So in that way, you can utilize each and every student property in one, and finally you will get a very good product. So that is also we just use in material. So we just add what is our requirement. According to requirement, we add those material, and that material property is mix it, and it gives you the better property than the parent material property. So that is called a composite. So composite is nothing but it is the mixing of the 2 or more distinct material which can together produce the synergistic property. That is called a composite. And here you can the scattering electron microscopy, we are using the fiber, matrix and interface. So that matrix holds the so fiber is acts as a reinforcement, and this is matrix. This is provide the this particular strength over the reinforcement, and reinforcement provide the support of the matrix. So advantage of the composite, it is high strength to weight ratio, high stiffness to weight ratio that we needs. And if we can achieve this, we can save the weight. If we can save the weight, we can reduce the fuel consumption. If we can reduce the fuel consumption, we can reduce the emission of CO2 and NOx. And also, if we can weight is less, then noise is also can be less. So composite material can construct at the same time produce unlike other common engineering material, and it can gives you the good surface finish, less wastage, reduce manufacturing cost compared to other material. And it is composite can have the good fatigue property, good thermal property, good thermal and acoustic insulation benefit. And according to if we can add the fiber and resin in each proportion, then we can create the material property according to our need. So that is the main thing, how much quantity we need a matrix, how much quantity we need the reinforcement. If we can select properly, add it and fabricate the composite, then you will get the desired, you will achieve the desired property, whatever it is requirement. Disadvantage of the composite is nothing but its initial cost is very high. It can behave an anisotropic nature. It can sensitivity to the humidity. So we can also work on these aspects, how you can reduce this sensitivity towards the humidity. And test method also we need to develop so that we can test each and every aspects of the composite material, mean tensile strength, fatigue strength, creep strength, and other properties. So test methods needs to develop, because slowly we are moving the 180% composite material in aircraft. So in aircraft, the several things has happened, several loads are occur. So we will see in further slides how the loads occur in the aircraft. So these are the classification. We can go for either matrix type, in reinforcement type, in matrix type. Three types of the matrix are most widely used: polymer matrix, metal matrix, and ceramic matrix. But polymer matrix is nowadays is used in that particular self-healing composite. Reinforcement is different kinds: viscous, particle, fiber, structure, and these are the further subcategories on the reinforcement. So these are the basic classifications. So several fibers, you can see that these are the synthetic fiber which is available in the market, and these are the natural fiber. So natural fiber is having the less strength than the synthetic fiber. But if we want to buy composite material, then we go for the natural fiber rather than the synthetic fiber. So how much percentage we just add in synthetic fiber in natural fiber so that we can get the better property, better stiffness. So according to that, we just selected. So this hemp fiber you can see here, it is approximately epoxy glass fiber stiffness. So according to that, we just select hemp is widely used. Then flax is also used because flax is having more stiffness, and other things, approximately this aramide and this. So flax, hemp, these are the fibers which is used in that particular as a reinforcement. So matrix is nothing but we can use the epoxy one, polyester, these are the thermosetting, or metal one, or ceramic one. So we just select nowadays the epoxy one, that is it is very good. Peak and other things, we can't use that one. But according to the mechanical property, if we can use the metal, then the mechanical property is good. But if we can use the polymer, then the mechanical property is poor. So how you can, our target is how we can improve the strength or mechanical property of the polymer. What those composition we just added in reinforcement, which type of the reinforcement we will add in the matrix, so that we will get the but as similar, not greater, but at least similar to that particular metal. So in this way, the research is still going on, and we are developing new material by adding the graphene or multi-wall carbon nanotube or natural fiber. Also, we are adding to improve the strength and other property. So these are the various characteristics of the matrix which is required in terms of the mechanical and thermal, in terms of the processing characteristic, in terms of the chemical properties. So these are the various characteristics which is very important in selecting of the proper matrix material. So this evaluation of the material already I explained earlier in Feb, but you can see here in 10,000 VC to up till 2020 how the material is developed as our requirement. So initially we only have the stone, flint, pottery, glass. These are the ceramic materials. So wood, skin fiber, straw bricks. So these are the oldest material. After that, according to our requirement in polymer, glue will come, then bakelite will come in 1900, nylon will come, then nowadays we are using the high temperature polymer also, high modulus polymer. These are the generation, and this in carbon reinforcement fiber, aluminum, this AFRP also, GFRP also. So these are the composite initially developed, so that after development of these composite in this era, we increase the concentration of the composite in the aircraft industry after evaluation of these composite AFRP, CFRP, GFRP. And this superalloy, zirconium alloys is also developed nowadays, and this develops earlier. So nuclear power plant superalloys, this zirconium is widely used in nuclear power plant. So nuclear power plant is also booming nowadays. So these are the structure, how the material developed as our requirement. So now we are further developing the composite material which is in a biodegradable in nature, which not affect the environment and also reduce the weight of the material. So back on the future again, you can see here the Egypt. So Egyptian and Mesopotamian stelae use the mixture of mud and straw to create a strong and durable building, and those buildings still it is good if you maintain properly. So Egypt is maintain that property, and it can increase the tourism in that particular country. So mostly Egypt is only developed, only earn the money from the tourism only, and nothing is there in Egypt. Only Mesopotamia and Egyptian, these are the buildings, whatever they have. But in our country, that is very poor. Nowadays, slowly we are increasing the tourism. But previously, we are not able to sustain our fort, which are old. And if we can sustain, then at least we can also improve the tourism. So that is that's why India is lacking in tourism. But slowly in Modi government, we are targeting to increase the tourism. And nowadays, tourism is improved approximately 5 to 10% in India. And sealed off this particular sealed in war, you can see two external laminates of the hard bronze and two internal ones in the tin, and central laminate of the pure and soft gold. So these type of the sealed is used in the war in that type of the ancient Greece time of the, and this is the Egyptian times. And this wings, whatever previously this fully morphing materials is fully biocomposed, close to zero. These are our future goals, and joining of the structure is more adhesive in nature. So these type of the wings means if sun rays or some temperature is improved, it will not burn. So that's why we are developing that such type of the material, so that it will not degrade. So these are the picture. This is self-explanatory. If the sun rays, the heat is increased, then what happens is the wings can be burned and it can drop down. So that is the thing. So we are also, if sometimes fire happen in that particular aircraft and other temperature increase, then it will not affect the material of the body. structure. So that type of the structure we need, and more adhesive in nature so that it will not destroy. So light structure design philosophy, we just go into nowadays. So light structure is a matter of design, not a matter of weight. So how you can design properly, that is very, very important. Not weight. So material selection is one major driver in the light structure in design philosophy. First, we select the material. So nowadays we are targeting the magnesium also, because that is a very light material. So the main criteria of material selection is specific property of the material, like Young modulus, ultimate tensile strength, yield strength, and these are the specific one per density. So specific Young modulus is nothing but Young modulus divided by the density of the material. That is called a specific property. So ductility and fatigue behavior are also essential concern in that particular selection of the material. Because you can see here the forces on the airplane, the 4 forces in the airplane, it is very important. It is moving forward, then thrust force and drag force, then weight from the center of gravity, and the lift. So these forces, thrust, lift and drag, it can act over the aircraft, and due to that controlling of these forces, we can fly, and we can take off, and we can land that particular aircraft. So aircraft structure requirement, when we perform the material test or material selection, we needs the impact strength more here. Hoop stresses is developed in the cell. So we can design the hoop stresses by the thin cells strength of material. Shear stresses develops because here the material is joined and the shearing occurs over this surface. These surfaces the shear occurs. So these surfaces the shear occurs. So that's why this here mention the shearing. Then here what happened, the compressive forces act. So this flap apply the forces over this. So compression is occur. And here in this bottom, the corrosion resistance is more important because we needs the this is the chamber of where we can fill the goods, and we also fill the lubricant oil. And these are the flaps where the bending force is very important. Here the torsion force is very important. How we can control the crack growth, high local loads, because here the jet engine runs and the high local loads is applying, and here longitudinal stresses is developed. So these are the plane stresses. So so when wings drop down, that goes under tension and under compression. So these things we just take care in designing of this flap. So due to this tension and compression, this cracks develops over this particular flap. So we can control the material. So we can control these loads. So these are the very important mechanical properties which is required, and these are the design parameter. First, you can select it, the material. According to the selection of the material, we just perform the simulation by taking care account of these mechanical properties. So we just aircraft structure material is nothing but we can go for like 2024 T3, that type. The main alloying element, aluminum base is the main alloying element, and the element we just added in that particular one to improve the structure strength. So you can see the ultimate tensile strength, Young modulus, density, elongation of fracture. It can improve like aluminum 7075. So that is widely used 7075, where these are the other alloying element, and it can possess the more strength. Magnesium based alloys having this more than 97% magnesium, and other alloys aluminum and zinc. So these kinds of the alloy, it is called a AZ31 or AZ91. In that particular one, we just add the 9% aluminum and this particularly 0.5% zinc, and aluminum is also added. So these are, you can see the ultimate tensile strength is also improved in the AZ61AF. So according to the alloy, we just add the element and we just tested these material, ultimate mechanical property. That is very, very important for structural application. Similar case, titanium based alloy, if we can add it, we can see in titanium based alloy, we will get the better ultimate tensile strength, better Young modulus, and other property too. Nickel based alloy, further more than the titanium one. So Inconel or Neomic 80A, it gives you the more tensile strength, more Young modulus. So these are the newest material which is used in that particular, after the composite, we just use these type of the material in fabrication of the aircraft structure wherever metal is required. The composite material in aircraft industry, you can see here the carbon fiber reinforcement unidirectional composite gives you this strength, Young modulus, and this, but glass fiber reinforcement composite very less Young modulus than the metal. Kevlar fiber, these are the biodegradable fiber. Boron fiber, according to that, ultimate tensile strength, Young modulus, and these are the composite material in aircraft structure. So according to our need, according to our application, either cargo base or this particular taxiing or something, passenger based aircraft or space aircraft or this you can say fighter aircraft, what type of the aircraft you are making, you want to develop. According to that, we just select the proper material. After proper material, we just do the testing. That is very important. So this metal versus composite material, these are the differences. We can give it you here in comprises that in terms of density, specific and modulus, and specific strength. You can see it composite nowadays. We just achieve approximately more specific Young modulus than metal. So, and also the Young specific strength in the composite, we can achieve more than this particular metal one. So Kevlar fiber or carbon fiber reinforcement, that's why this carbon fiber reinforcement is approximately 60% is used in that particular aircraft, or Kevlar fiber reinforcement is also used because of the high strength and high Young modulus. So composite material having the disadvantages, high strength to weight ratio, you can tailor made the mechanical property in various directions, corrosion resistance, impact resistance, design flexibility, also it can have the fatigue resistance. But in case of the metal, it is complex, safe, high ductility, damage resistance, conductivity, because chances of the crack propagation is also more in that particular metal, and cost effective, that is the one. Joinable by the various methods. So these are the metal, but in composite we can't join the various material. That at least we look into that. And drawback in composite material, you can reduce the electrical conductivity, brittleness, inferior fire resistance, unpredictability, lack of recyclability, like in thermosetting if we are using. Heavy structure, prone to corrosion damage, inferior creep resistance. So here in composite material, we need to improve the creep property also, apart from fatigue property. Then, and also we can look into the recyclability of the material, because in metal you can recycle it, but composite, if you are using thermosetting, then it can't recyclable. Then that you can just take care. And also this composite material is having brittle in nature. So how you can improve the toughness and other property, and a little bit softness we can incorporate it by adding some material. So that we can just, still research is going on. So this is the basic difference between metal and composite material. So thermosetting and thermoplastic, like thermoplastic is high recyclable, high impact strength. Remolding, reshaping can melt if heated, generally more expensive than the thermosets. Thermosets is more cheaper than the thermoplastic. So here cross-linking is happened, but when you provide the heat again and it again link is broken. But if you provide the heat, even though these links will not grow. So these are the cross links happen, but here no cross links has happened. it is cheaper than the thermoplastics. So it is chemically resistance, but it is thermoplastic is chemically not resistance. More difficult to surface finish. It can achieve good surface finish. So this is the basic polymers which are used in the fabrication of the composite structure. Novel manufacturing techniques, that is also very important, how you can manufacture the things. So laser welded aluminum fuselage panel. So if you can fuse like panels, we just use this type of the heat affected zone. That is the in manufacturing techniques. So sometimes we just use the thermoplastics component like this, and this you can buy metallic integration structure based on the specific manufacturing such as welding, casting, forging, large scale extrusion, and high speed machining. This permits the modular prefabrication of large sections of aircraft before final assembly. So this is the nose aircraft canopy. So helicopter canopy we can make by thermoplastic composite material. So different kinds of the material we can use that particular different. We just select the different material and different processes. And the future aeronautical material, it is called a multifunctional material. So we have the polymers in that particular one, so it can polymerize it, and it can also having the healing agent. So what happens if this is the composite material, this, and you can make and you can send some healing agent like this. So these healing agents act as a packets. So when cracks develops here, so what happens? This healing agent can be can burst here, and the whatever the healing agent in packet, it can remove, and it can fill that particular body. So it can self-healing property, it can be improved. So like in Hollywood movies, you have seen Wolverine series. You can see that particular Wolverine, it is having the self-healing property. If something is a strike in that particular body, it can again reheal it, and it can close that particular impact. So self-healing properties mostly in also in animals is also available. So because of that things through natures, we will also produce the self-healing material. So material system consists nano or micro substitutes. We just add the fillers, either graphene, graphite based, whatever nano additives, which can exhibit either reinforce structural property, it can demonstrate at least additional function. So that type of the material, it is called a multifunctional material. So it can polymerize this packet burst due to the crack. So this healing agent come out, and it can fill that particular cavity, and it can close the surface. So this self-healing material, it is widely used in spacecraft when it enters from the Earth zone to our universe. So that's why due to the higher friction, this sometimes cracks develop, and those cracks immediately can be filled out automatically. So that is called a multifunctional material. Then another material which is very strong, that is a graphene. That is a new in this our 20th century development of the material, and that material is very strong. It can also hold an elephant, that much strong. So Young modulus is 1 terapascal, and tensile strength is 1100 gigapascal. So graphene is most strongest material, means the strongest material it developed in 20th century. And if we can add these nano graphene inside the matrix, then we can improve the strength. And that type of the reinforcement is called a carbon fiber reinforcement. So this graphene is nothing but the allotrope of the carbon. So this carbon fiber reinforcement composite. Another is multi-wall tube, carbon nanotube, and these are also used in advanced composite materials. So Young modulus is 1 terapascal and tensile strength is 60 gigapascal. Electrical conductivity, so wherever we need the electrical conductive composite material, then we just use the carbon nanotube. So this is widely used in electrical industry, the composite material which consists the carbon nanotube versus the better electrical conductivity. So these are the structure of the carbon nanotube. So this is also a future aeronautical material. So self-healing material, as I already told you, it is also a multifunctional material. So structure of polymer are susceptible to damage the crack. So like this is the polymer material where you have some catalyst or microcapsules you have inserted. So when cracks propagated, so this cracks propagated and it can burst this healing agent. And this healing agent can be come out and it can fill that particular one, and this polymerized healing agent, and it can be fill the gap. So self-healing material have the ability to automatically heal the cracks inspired by the self-healing biomaterials. The material incorporates a micro-encapsulated healing agent that is released upon cracks intrusion. And after this cracks intrusion, the healing agent come and the polymerization reaction happen. And this due to the polymerization, the healing agent then triggered by the contact with the embedded catalyst and bonding the crack phase. So these are also a future material, and nowadays also in spacecraft we are using the self-healing material, and it can automatically repair the material if some cracks develops. So problem to be solved: to take the advantage of the improved properties of the multifunctional material, there is need to access the effect of additives on the mechanical behavior, possible degradation of the mechanical behavior of the material, that also you can solve it. So we just use the new multifunctional material which can reveal the significance of the material production quality on the entire multifunctional material concept, and which affect directly the degree of internal defects. And you can these techniques should be affordable effort and less cost, would appreciable, and also it can enhance the use of this promising characteristic of the material in aircraft structure application in future and nowadays also. So nanocrystalline material is also used. So metallic alloy with grain dimensions in the order of 100 nanometer or less, these are called a nanocrystalline material, and in future we can also purchase the nanocrystalline material, and because of the high huge increase in the yield strength after adding this nanocrystalline material inside the matrix. So what about the ductility and fatigue strength after adding this nanocrystalline material? So that is still research is going on after adding this. So if you can also take some nanocrystalline material and add in the matrix, and you will perform this test. So by adding this nanocrystalline material, it can improve the significant materials property at ambient temperature, and the objective is driving force by producing the metastable equilibrium state. So kinetic mechanism is reduced mobility, does not eliminate free energy, driving force. Thermodynamic mechanism is creating of the metastable equilibrium state, driving force eliminate at the critical grain size. So that is the very stabilized material, nanocrystalline material, which is also is the future material for aerospace applications. So these are the few mechanical properties of nanocrystalline material, adding in that different base alloy, aluminum, magnesium, titanium, and nickel. We can check the particularly different mechanical property according to our aircraft metal. So these are the future of aeronautics. So These are the different NASA images I have taken. So this terminal-based offshore means inside the sea we can go from one place to another place. That is also there, and these are the future of airport. So this such kind of the airport is also being developed. Monorail will also use to transport from one place to another place. So these are various applications of the composite material in different applications. So boats, sports equipment, cars, power generations, and building and structures, bridges. So I hope you enjoy this lecture, and thank you very much from my side. Now floor is up to you.
Thank you, sir. Students have already posted some questions, sir. We'll go one by one, sir.
Okay.
And there is one question from a student. He's asking, composites can be recyclable. He's asking, what are the opportunities available for an aeronautical engineer in such industries where they do recycling composite?
Okay, I'm just go one by one.
Yes, sir.
Okay, in aero industry, all material in aircraft can be recyclable or not? No, all material are not nowadays recyclable. So we need to develop such kind of the material which is recyclable. So if you are using thermostats matrix, then thermostats is not recyclable. Only thermoplastics is recyclable in matrix. What are the opportunity for aeronautical engineer to work on recyclable company? So it is having a more opportunity if you develop some kinds of material which can be recyclable. So we just go for some biocomposites. Those are recyclable composite or biometal matrix composite. Then you will get a very good job in this aeronautical industry, because our future is very bright in aeronautics regarding the material aspects. Are there composite which has properties similar to the gold? Gold is very ductile material. So gold is a very, very ductile material. We never use the pure gold. In gold also we just use the copper and some other impurities to improve the strength. So composite is much far, the properties is composite is much far than the gold. So as I told you, as I showed you in few slides how the composites property, and you can compare with the this particular property. 1 minute, sir. One call is coming.
Yes, sir.
Oh, sorry for interruption. Actually, one call came. I ordered some AC from Amazon, so present delivery came.
Okay, sir. Okay. We'll continue.
So this question is not that much. This gold property is totally different. We never use this. Composite is much better property than gold. Another question is, sir, in the two-engine blast event on the Boeing 7, fatigue is blamed. How will this affect the development in ceramic or composite-based diffuser blade? So this diffuser blade is Nowadays, we are targeting by the single crystal material, not go for the ceramic and composite based material. So single line modern casting method, this Kocharsky method or floating zone method, where we can use the directional solidification and chills, and we develop the single crystal, means there is no grain boundaries. So that is used in the blades. And we can, this composite materials are also used in fabrication of that's wind turbine blades. So we can go for the carbon fiber reinforcement composite or glass fiber reinforcement composite to provide the better strength and less vibration. No, there is no plotted table according to need. No guide source is available to choose the perfect material. Only our requirement, we just go for the simulation one, and we just check the property through the simulation. And then that's why the CFD analysis in the structure, it is very important in aeronautical. So structural CFD analysis, you just first perform, and then we can go for the experiment. There is no shortcut in that particular one. Safe memory alloys is also, that's why I am telling you in last slide, this self-healing material or multifunctional material, those are the category of the safe memory alloys or smart material. Metal tends to have better performance over a wide range of temperature, whereas the composite tends to get very low temperature. So there is anyway composite primary building material for airplane. Because if we add the matrix reinforcement in such a way that, so extreme environment also, this composite can go up to 950, 950 or this. So these are the composite. Slowly we are developing like ceramic based composite, this carbon fiber or glass fiber. These are the ceramic based composite material, and it gives you the better in this higher temperature range. Metal is surely better in higher temperature range, but it improves the weight of the aircraft. Graphene is nothing but allotrope of the carbon. Okay, so graphene is also used in the composite material as a filler. 100% composite nowadays still it is not possible, because landing gears you can't make by the composite, as I told you that the vibration, shock and other things happen. So that composite can't take. So at least few material requires the metal. We can't use the 100% composite material in the aircraft. I hope all the questions.
Yes, sir. I think we have answered all the questions, sir. Yes, sir. Sir, shall we conclude, sir?
Yeah, sir. Yeah, sir.
Okay. Thank you, sir. Thank you for the session. Now I call upon Dr. H. Ramogan, Honorary Secretary of Institution of Engineers, Coimbatore Local Center, to give away the vote of thanks. Sir.
Thank you, sir. Very good afternoon to everyone. It's a great pleasure for me to deliver vote of thanks. I thank our beloved Dr. P. Natarajan, Chairman, Institution of Engineers India, Coimbatore Local Center, for his welcome address. We thank Mr. V.T. Govinathan, Head of the Department of Aeronautical Engineering, Hindustan College of Engineering and Technology, Coimbatore, for accepting to preside over the webinar. Thank you, sir. We thank Mr. V. Kumar, Assistant Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology, for introducing today's guest speaker. Thank you, sir. We thank today's chief guest, Dr. Jitendra Kumar Katiyar, Assistant Professor, Department of Mechanical Engineering, SRM Institute of Science and Technology, for excellent chief guest address on advanced materials in aerospace. Thank you so much, sir. It is a very wonderful and highly informative webinar today. Thank you a lot, sir, please.
Yeah, thank you, Ram Mohan sir, and
We thank the management.
and thank you, Head of Department HICET, for giving me an opportunity to interact with the student and other staff of HICET. And I hope everyone enjoy this lecture and something everyone gain from this lecture.
Yes, sir. Thank you, sir. Raman sir, I think you can continue, sir.
I think some network issue from the Ram Mohan sir side.
Yes, sir. Yes, I think so. We'll wait for 2 minutes, sir.
Okay.
Yes.
No, sir.
Sir Raman sir, whether you are available, sir.
I think some network connectivity issue.
Yes, sir. We are contacting them, sir.
Okay, no issue,
Yes,
sir.
sir. Okay, sir. There is an issue. We'll conclude, sir. Thank you, sir. Thank you for second time. I think second time we are meeting, sir. It's pleasure for us.
Sir, in future
Listen
also
to you.
we'll meet again and
Sure,
again.
sir.
I will deliver this
Sure, sir. Sure, sir.
some information to the student.
Definitely, sir. Definitely. We'll meet, sir. Thank you, sir. Thank you so much, sir.
Within a 1 minute, somebody is joining. Some message came.
One more question, sir. Yes, please, with 1 minute, they are asking us to wait, sir. We'll wait, sir. Yes.
Okay, sir.
So there is one question also. Can you tell any one of composite metal that has high heat resistance and strength?
Current material is no such kind of the material is still developed. So we are only single crystalline structure is more used in that particular fabrication of the turbine blades. Those are the high strength and good surface finish. No machining is required, and also it is having the good dimensional accuracy. So those type of the single crystal material is only nowadays in that particular fabrication of the turbine blades. This carbon fiber reinforcement composite or this glass fiber, both are having more or less same height, heat resistance and strength. So little bit difference is there, but these are the composite material which is having the high heat resistance and strength.
Students, if you have any question, you can ask now. Sir is available with us.
I think I have taken more time. What time
No,
you
no
have
problem,
allotted?
sir. No problem, sir. That is not an issue, sir.
I have taken more time because that lecture, it is more than 1.5 hours.
Yeah, because many of our final year and pre-final year students are doing project in composites, sir, especially natural composites. So I think they are interested to listen. So that is why. No problem, sir.
Okay, sir.
Sir, there is a question. Please suggest a material which will resist heat and strength. I think we have answered it.
I have the same
Yes.
question asked
Yes.
earlier.
Yes, sir. Yes, sir. We have answered. Yes, sir. Sir, okay. There is some network issue, sir, with Ram Mohan, sir. He has messaged. I will conclude the meeting, sir.
Okay, thank you,
Okay,
sir.
sir. Thank you, sir. Thank you all. Thank you all. Thank you to the students, faculties, and others those who have joined. Thank you, sir. Thank you, sir.
Yeah, thank you to all of you, and have a nice weekend to all of you. And great ahead weekend. Enjoy it.
Thank you, sir. Thank you so much, sir.
Okay, sir.